Testing, testing. We live? Think we're live? Let me make sure we're getting a good... I'm not sure this is... Oh. Is it just me or is there a delay here? No, I think it's fine. I think it's good. Okay, nice. Okay, welcome one, welcome all to, let's see, today's Sunday, July 31st, the last day of July. We are here to do another LeetCode live session. It looks like we had some people waiting, so thanks a lot for joining in today. Hopefully this can be a good live stream. We did our weekly roundup yesterday. We went over a lot of different questions, ones that we weren't able to complete during this past week. I always like to do those just to sort of get a refresher and then set ourselves up to go back to these sort of normal LeetCode streams that we do on the weekdays. Although, well, today's a weekend, but I think you understand what I'm saying. So, yeah, I don't think I have any really housekeeping to do. Besides that, hopefully everyone's Sunday has been going good. I saw the movie Nope last night. Thought it was pretty cool. I won't really talk too much about it in case anyone hasn't seen it. I would just recommend you go see it. And had some really good food for dinner. So that's always a plus. I'm definitely like a foodie. It's one thing I enjoy a lot. So I'm gonna like scroll on this stream real quick just to make sure that, because I know I can always expect some delay on the stream, but I started the stream a little bit differently this time. So I think what I'm seeing there's a delay, but I don't think what you guys end up hearing is delayed or anything, so that's fine. Let me know if anything sounds off, or if things aren't just like working the way they should. That'll be good. Okay, sweet. So let us go and start. Actually, I want to talk about some of the highlights here. So some of you may already know that we already passed our 100 question mark, which I think is awesome. And as of today, we're past 100 subscribers, which is doubly awesome. So I think that's super cool. Let me also make sure, which I think is awesome. Okay, cool. So the sound's coming in fine. Okay, sweet. So yeah, without further ado, let's go ahead and get started. So we left off on the second page. We're just here going through a ton of different easy questions. Like I said, my intent is to do every single easy question, then every single medium, then every single hard. I know it sounds crazy, but we'll do it. I've been learning a lot, even through easy questions, so there's always something to learn. Let's go to the second page here. All right, where are we? Okay, sum of root to leaf binary numbers. Let's see. You're given the root of a binary tree where each node has a value 0 or 1. Each root to leaf path represents a binary number starting with the most significant bit. For example, if the path is 01101, then this could represent 01101 in binary, which is 13. For all leaves in the tree, consider the numbers represented by the path from the root to that leaf. Return the sum of these numbers. Now, does it want the root of this whole thing? So it would be like 101. Let me see, 100 plus 101 plus. Okay, so this is, there's another question that's very similar to this one. I think it's just called like the sum to leaf or root to leaf sums or something. So, I mean, one thing that I think of here is we can sort of do if you think about doing like a post order traversal, so we calculate this one, or we start here, then we go down, we visit this is null, so we come back up, and at this moment we should have some sum that we've kept throughout this whole time, and now we can start adding it. Now I think the way that we're doing this, so which one ends up becoming the most significant bit? Is it 100? So this should actually be, it shouldn't be, yeah, I think what makes this a little bit tricky is it's not like, if it was 001, or if by the time I got to the bottom here, I already figured out sort of like the height of the tree, which I guess we can do like a pre-processing step to figure that out, assuming that this is, these might not always be the same height, I'm guessing. 01101, which is 13. It could represent that. So how is it that we want to do this? How would we know from the beginning, or rather the end, right? Because we'd have this one, and then we'd have this one, then we'd come up here, but now it could be could be two different ones. Now, if I start from the top, is there any way that maybe doing this iteratively, given the root, each root to leaf path, binary number starting with the most significant bit, number of nodes in the tree is range, no value is 0 or 1. The thing I'm struggling with a little bit again is just the like that first number 101, right? If we sort of break this down and think about this. Hello, Raphael. Thanks for always hosting these sessions. Hey, Rashawn, how you doing? Really appreciate you joining in. It's great to see such a familiar face around here, and I really do appreciate you being consistent with your, I guess, attendance. So that's very awesome. Thank you so much for joining. Really, you guys are the ones that make this all worthwhile for me to hopefully teach something and learn myself. So I think it's pretty neat. If we sort of break this down here and we think about the representation of this number, right? It's going to be like 2 to the power of 2 times 1 plus 2 to the power of 1 times 2, or rather times 0 plus 2 to the power of 0, and I should say this times 0, right? That's really what it ends up being. That's how you sort of like represent this, right? Because we have 2 to the power of 2 is 4, times 1 is 4, and then all the other bits are turned off, so we never actually account for their value. So how can I know? So like on that first case, 100, I need for it to be 4, which means that the first thing in the root should be to the power of 2. But how would I know that already? I don't want to assume that all these are the same length, because you could imagine that one of these is going to be a longer path than the other. They don't all need to be the same length, right? So let me think about this. Let's see what we can do. I'm going to open up Excalidraw and sort of just draw this tree. So we have a 1, 2, 3, 4, 5, 6, 7. Okay, so let's go ahead and draw our 7 circles here. Make them as nice as we can. Okay, I'm pretty happy with that. Something like this. Let me just start. The reason I want like an accurate representation here is because I don't want to make a cruddy drawing, because having a good drawing actually helps. So we have 1, 0, 1, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Okay, let's see. What's the best way for us to tackle this? If I start here, I don't yet know what my power is. And I can't just like arbitrarily say that the height, because maybe the height of this tree is 2, right? But they all end on the same level here. So if I got the height first, I would sort of know where to start. Let's see. 0, 0, 1. I guess does it really even, does it matter? Oh no, it does, because as we're going down, what if we started from the bottom here? Right here we'd have a 0 times, or 0 to the power, I'm sorry, 2 to the power of 0 times 0. Let me like write this stuff out as we're figuring it out. So 2 to the power of 0 times 0. Here we'd have, let's just consider these left ones here. 2 to the power of 0 times 1, right? Now over here, like we can add this one, like we'll come up with some sum here, I guess, but it'll be sort of like 2 different ones that we're returning, because I want to capture the one that has the 0 here. So this would be like 2 to the power, what would this be, right? 2 to the power of 1 times 0. But then we're going to add it to this one over here and also this one over here. Maybe this gives me some amount back, and then I can do the same thing up here. Is that something that we can do? We can sort of get like 2 sums from each one. Now, if it goes deeper than that, are we always just doing 2? So what I'm thinking here is like on the left side, let's say we return the 2 to the power of 0. So 2 to the power of 0 is 1 times 0 is 0. So let's say on the left side we get a 0. Here on the right side, 1 times 1, right? We get a 1. Now we can sort of return an array where we're starting to add these up, right? So this would be a 1 0 0. Here we can do this would be 0 0. So 2 to the power of 1 is 2 times 0. So now we sort of have an array that has like a 0 0, and then maybe we'd have an array that has a 1 in the bottom. That's the thing that we got all the way on the right side, and then 2 to the power, right? So we'd have something like 0 1 over here. And then when we return it here, can we now just say, okay, my left has these numbers that we've started to build up, and now I just add the result of this plus everything in this array, and the result of this plus everything in that array. Is that something that we can do? The only reason I'm a little bit skeptical is because I want to see what happens if I go a little bit further. So let's copy like some other circles down here. And yeah, we can leave these as 1 1. So let's just consider this right side now, right? We have more data here. This is often like a good thing to do during an interview. Sometimes the examples you get or the examples you think of are very contrived, happy case examples, but I think it's worth it to really try and think of an example of something that you actually wouldn't want to happen, because if you can handle that case, then you're probably pretty good. So you can almost think, oh, and wait a second, so would this also be considered too? I guess it would, right? Because these leaves are further out. But anyways, let's go right. So both of these would be 1 1 1 1 and 1 1 1 1. So over here again we have 2 and 0, 2 to the power of 0 times 2 to the power of 0 times 1, and 2 to the power of 0 times 1. So what do we have here? We have on the left hand side we have 1 times 1, and on the right hand side, right, we have 1. So we can sort of return this like array from here. Anytime it's a leaf node, we just get these two numbers, and if it's not, we could just return an array that has those values. So I'm almost thinking of doing something like this, 1 and 1. Or no, we'd actually have to add, right? We'd have to add 2 to the power of 1 times 1 to each one of these. So that would be a 3. Effectively, we're returning an array of 3 and 3. I hope this is sort of making sense. It's a little bit, I might be making this problem more confusing than it needs to be, but let's just keep it going. So imagine we return like 3 3 here, right? Now we do the same thing with 3 3. Oh, okay, I guess I left that one back there. With 3 3, what if I now do 2 to the power of 2 times, right, 2 to the power of 2 is 4 times 1, so that becomes a 4. We can add that result to here, 7 and 7, and then we come over here. This is a 0, but this becomes 2 to the power of 0. 1 times 0 is 0, so left hand side is 0. So let me see if I can come up with an algorithm here. I think this could be a way of doing it. Maybe there's another way, but this is at least how I'm thinking about it. And I'd love to, like, any thoughts you have, or you want to just, like, you want us to go back and forth with like different solutions, I'm totally game for that. So just feel free to, you know, drop something in the chat if you have thoughts. Let's see what we can do here. It's always a special case when we have this leaf node, right? So what happens when we have a leaf node? When we are at a leaf node, we'll just return 2 to the power of root.val. Guess we can just return this single number. And then if we're not, what is it that we want to do? We want to add, I guess at any given node, at any non-leaf node, get left and right values. left and right values, and then come up, we will do like get value at this node, which is 2 to the power of, I guess, whatever our depth is. Oh, that's tricky. How can I also, do I also have to return the depth? There's got to be a simpler way of doing this. I might be, return the sum of these numbers. Maybe I might be thinking about this too. This might not be the way of going about it. 2, 2, 1, 0, 1. I mean, I could also just generate all these and add them that way, but that doesn't seem great. Path and root at leaf, return the sum of these numbers. By the way, something new that I'm going to start trying out is, I've heard before that easies should take 20 to 25 minutes. So for example, right now we're approaching 16. If I don't get to it within 20 to 25 minutes, that's going to be sort of my new metric to just continue on to the next one. That way we just sort of save time and we can try to get to as many questions as possible. And then I'll just save these for weekly roundups. Yeah, I'm definitely struggling with trying to figure out how to figure out this depth. Unless, again, I don't want to assume, is this a, shoot, sorry for no significant bit. Answer fits in a 32-bit. The number of nodes in the tree is ranged. There's nowhere here that it says this is going to be a complete height balanced tree. Should I just try to do it the other way where I figure out the height and see what that gives us? Let's try that out and see what happens. I'm gonna have, this is sort of like another easy question in and of itself, but trying to figure out the depth. I'm gonna assume, this is definitely something I'd recommend for you to, I'd recommend you going over this with your interviewer, just to make sure, in this case, where I'm assuming here it's a complete height balanced tree. So if not root, I can just return 0. Else I'll get my left equals depth of root dot left. I'll get my right equals depth of root dot right. And I'll return math.max of left and right plus 1. Let's just see what this does real quick. Let's just do the same thing here. We'll just return 0. Let's do the depth, const depth, tree depth equals depth of root, console.log, tree depth. And I'll also just like return something here. I mean, I guess we can just return tree depth. This is just for me to see, just to make sure this is right. Okay, 3 and 3, okay. Or I got 3, which is what, is that what we expect? 0, 1, 2, maybe I don't even want to go to, what if here we say if root, if not root dot left and not root dot right. Okay, I do want it to give me 2. So using this now, this is sort of a, yeah. So we get our tree depth, right? And now I can do something like const. Gonna be starting from video 0 today. Oh, that's great. Trying to catch up to you. That's super cool, Sugoi. Yeah, so just a quick note. Well, let me actually get to the, let me see if we can do this real quick and then I'll talk about that because I want to follow up on something you said, Sugoi. So calculate, let's say calculate sum. We'll create a new function here. And then finally here, I'll call calculate sum with root. Let sum equals 0. Calculate sum root. Well, I guess here we can just do sum equals calculate sum root. And Actually, we don't even need that. We can just do return calculate sum root. So calculate sum, now we have the tree depth and we have the root. So what we could do is we can start just going down here, right? Like if we get to a leaf node, if not root, we'll also take depth here. I'll pass in tree depth. I can say if not root dot left and not root dot right, we can just return. I can return math dot power. Is it power or pow? I think it's math pow. We can do return math pow 2 to the power of root dot val. Oh, and do we want to? No, this definitely needs to be 2 to the power of depth times root dot val. Here I can say const left equals calculate sum of root dot left and depth const right equals calculate sum of root dot right and depth minus 1. Return left plus right. But is that going to do? That's going to be getting intermediary values. No, I only need to calculate this at the end. Yeah, this makes it way harder. I'm going to end up with something bigger here, right? Because I'm always calculating every intermediary value. 0, 0, 1. If I do 1 plus 4, that'll still be 5. 2 plus what? This maybe could work. 2. Wait. Calculate sum if not root dot left and not root dot right. Calculate sum. Obviously, I didn't even come up with like, yeah, const left dot right. Let's go down here, go down here. We're at a root node, so we come up here now. Then we go right, we calculate this one. Then we come up here. What we should do, yeah, we can still say return. So the left value, we can say return left plus whatever we did up here. This is going to look crazy. Math power 2 times depth times root dot val. And then maybe perhaps we can also say plus, sort of like the other way, right, math dot power depth root dot val. Could this work? Let's try this out. 14 and 22. So it got higher up there, but it's not exactly what we're looking for. Term power at depth minus 1, depth minus 1, left math dot power. Let's go through this. We start here, right? If not root dot left and not root dot right, no, it's not. So we go left, depth minus 1. So now depth is going to be 1 here. Okay, so we go left. All right, start here, return math dot power of 2 times 0, which is 1 times 0. So over here on the left, we get 0. Now we go to the right, times 1. So on the left, we have 0. On the right, we have 1. So I want to return 0 plus math dot power of 2 to the power of 1, that's 2, times 0 is 0. So now here we have a 0. And that's still only going to return, well, 0 plus what we had on the right times root dot val. Yeah, tricky. This is tricky because, again, my deal is like dealing with the depth. This is going to have to be something I draw out like on my whiteboard. I am going to like this question. I think it's great. And I'm also going to add it to my list, Rafael Negron list. And we'll go ahead and continue to the next one. Really good question though. All right, so I want to just quickly mention something that Sugoi did. Like for anyone watching here, the way that this works is I do these live streams. I've been doing them daily, and if you want to catch up to us and be, over 100 questions, the best thing to do is watch the LeetCode live playlist that I've created. You can start from this first video. So it literally says LeetCode Accountability Stream number 1, start here. You can see that we've changed a lot since this first one. And you'll even notice I didn't have a mic like I do now. So the audio on these first couple videos isn't what it is today. But it's pretty cool going through like how we've been evolving. I'm really, really happy with that. So yeah, thanks for mentioning that, Sugoi, and let's keep it going. So didn't get a chance to do this one. Let's figure out this next one. Maximum number of balls in a box. So you're working in a ball factory where you have n balls numbered from low limit up to high limit inclusive. All right, and an infinite number of boxes numbered from 1 to infinity. Your job at this factory is to put each ball in the box with a number equal to the sum of digits of the ball's number. For example, the ball number 321 will be put in the box number 3 plus 2 plus 1, and the ball number 10 will be put in 1. Given two integers, low limit and high limit, return the number of balls in the box with the most balls. Okay. So we can go from 1 through 10 for box number 1. Yeah, I think I know what we have to do. So we go through each one of these, right? For every one of these, we essentially figure out the sum of its digits and we put a ball there. And we can always sort of keep track of the max. So let's think about that. And at the end, we just say which box has the most. And if that number beats it, so what is it that we want to do? For this one, loop through every number from low limit to high limit. For each, calculate the sum of digits, place a single ball in that bucket, keep track of max. Anytime it beats one, we can just continue updating the max, else we'll just leave it there. So I feel like here I can say let max balls, let's say equals 0. We can say let max box. We can also say this is 0. And now what I want to do is write a helper function to calculate the box number. So calculate box number. This will be given a limit, since that's sort of how they spelled it there. Here it's just the classic, it's a trick that we can use to parse each individual digit. So let's say box number is 0 while limit is not equal to 0. I can say const digit equals limit modulo 10, box number plus or equals digit, and limit equals math.floor of limit divided by 10. Right, so we get the digit by using the modulus operator. We add that digit to box number, then we sort of truncate our limit, because in JavaScript you don't get truncation for free. And now we can just return box number. During this whole process, we can sort of keep a map. I think that would be a good way for us to do this. Let's say something like boxes is going to be equal to an object literal. And now we can say we don't need an initial condition since we're given low limit already. So for low limit less than or equal to high limit, low limit plus plus. This is like a kind of a cool way to write our for loop here, right? We don't need the initializer because we're already given low limit, so we just substitute or just add in the semicolon. For low limit less than or equal to high limit, low limit plus plus. Now we can say const box number equals calculate box number given our limit, given the current low limit, right? Inside of box, we can say boxes. So let's see, I want to calculate the max after I put it, right? Because then I'll see if it beats the previous max. So if it's not there, Yeah, let's do this. Let's go ahead and take care of putting it in here. So I can say boxes of box number equals boxes of box number plus 1 or 1. I made a short about this the other day. That's something sort of new that I did here, just showing you how to count frequencies of characters using JavaScript. This is something very similar. So the first time we get to boxes box number, there'll be nothing in there. So this will really just be, this will evaluate to not a number in JavaScript, which is a falsy value, right? So, or I'm sorry, this will evaluate to undefined, and then undefined plus 1 will be not a number, which is a falsy value. And because we have a falsy value on the left, this is sort of like a falsy value on the left of an or statement will choose the thing on the right. So just like a clever way of doing that. So we'll add it to the box number. And now we can say if boxes at box number is greater than max balls, then here we can say max balls equals to boxes of box number and max box equals box number. And then at the end, we should just be able to return our max box. So I believe this is at least how I would do it. Let's just run it and see what happens. I'm gonna move these. Well, so a couple things, right? Why did I do this commenting up here? It's very helpful for me to go through it slowly and logically like this. And I think this, I had an interview recently where it seemed like the interviewer wasn't too happy that I was doing this, which personally for me, that might almost be like a red flag, because I think I would value an interviewer that's being very methodical about their process and telling me every step of the way they're going. If they just rush into it and optimize it right away, I might think they just memorized it. But this really shows to me that they're careful with their logic, and they're making sure they're trying to put their best foot forward. That's one of the reasons I do this. I'm gonna move max balls and max box from here to here, and the reason I do that is because there's also sort of like a coding, I don't know if this is like best practice over here, but defining variables like next to the place where you use them makes it easier. Like imagine this is like a 1,000 line file and you have all these variables on top, but then maybe you're all the way down here and you want to see, oh, how was max balls defined or max box, and you have to scroll all the way up. So localizing your variable definitions, I think, is pretty cool. I think it's pretty helpful. So with that being said, let's just go ahead and run this. So we got output 1 and we expected 2. All right, so let's see what happens. So for number 1, 3, 2, 1 is 6, and the ball number 1, 0 will be put in box number. Okay. So oh, wait a second. The ball number will be put in 3, 2, 1. Okay, and the ball number 10. Low limit and high limit represent what? And balls? Okay, so low limit is my ball number. Here I should put boxes, box number. Okay. So in the box number. Well, that's fine though, because that's always going to be where that ball goes, no? The ball number 3, 2, 1 would be put in the box number 6. Ball number 1, 0. Return the number of balls in the box with the most balls. Oh, okay. It's not the box. It's the amount of, I guess, the amount of balls we want to return here. 2 and 2. Okay. We'll go over like time and space complexity now in a second. Two, 2, 2. Okay, we got all of them there. Let's check out if this passed. Okay, cool. Very happy with this result here. A nice sort of percentage in the 80s, which I think is nice. Let's go ahead and think about our time and space complexity here. So this function's an interesting one, right? This, from what I've seen in other sort of analysis and other videos, normally this function where we're picking digits off, it effectively sort of like halves the problem every single time, right? So it's just log of n, where n is just the length of the limit. So this is sort of like a log n function. So say this is O of log n. O of log n to do this. Now for low limit through high limit, right, we have to go through every single number. So it's going to be n times log n to be able to figure this out. Everything else here is constant. So it's going to be n log n for us to sort of figure out this whole solution here. This is what my analysis is, right? I have seen that an operation like this is normally log n. This is a linear time loop right here. It's going through every single iteration from low to high limit. So to me, it will be n times log n, which is the calculate box number. And again, everything else here is sort of constant. So again, n log n time complexity. For my space complexity, let's see, the thing that really is the bottleneck is this boxes map right here. And boxes will be equal, every single, I guess there could be, like if I had a ball, like a ball numbered, like ball 15 will go in the same box as ball 321, right? If I had 15 and 321, both of these equal 6. So they still go in the same box. So the box number, I guess it's just, probably we can just say O of n, where n is the unique boxes that we get from calculating all the box numbers from the balls. So I'm pretty happy with this solution, and I think our analysis is apt. So I think that's all good. Yeah, very happy with this one. I like this question a lot. I'm going to add it to my list. By the way, this list, let me just, what's the easiest way for me to show that? I'm kind of losing my place here. Let me just make sure we go back. Okay. Let me open this one. Sum to root, maximum number, k weakest rows. Okay. I created this list called Rafael Negron's list. Sort of similar to something you might think of this as like a LeetCode or Blind 75, but since we're going through every single question, I just wanted to make a list of all the questions that we've done so far that I think are worth doing, are high quality questions that give you a lot of leverage. So that being said, let's go to our next one here. Seems like another very high quality question, which I like, so let's get to it. We're given an n by n binary matrix mat of ones representing soldiers and zeros representing civilians. The soldiers are positioned in front of the civilians, that is, all the ones will appear to the left of all the zeros in each row. A row I is weaker than row J if one of the following is true. The number of soldiers in a row I is less than the number of soldiers in row J. Okay. Mat and K, both rows have the same number of soldiers. Return the indices of the K weakest rows in the matrix ordered from weakest to strongest. So if we're given mat, and what is K? We're given n by n matrix mat of ones, and what's the K? Oh, K weakest rows. Okay. So 1, 1, 0. A row I is weaker than row J. Now, return the number of soldiers in row I is less than the number of soldiers in row J. Why is it a different 2, 0, 3? So 2 is less than 3. Okay, this one's weak. This one's weak. This one's weak. This one's strong. Return the indices of the K weakest rows, weakest to strongest. So the weakest would be the one with the, let's see, if we just draw this out here, I think it'll be very easy. Now, anytime I see something like this where they want us to return the K of something, probably the easiest thing to do here would be to use a heap. Now, if any of you have any experience in JavaScript, you know that we don't get this for free. And I haven't had, it gives me different complexities. Like it's faster than 80%, then run again, it's faster than 60%. Yeah, it's probably just dependent on whatever server your code's being executed on. So go ahead, that's what I would imagine. So let's figure out like the weak index here. I also realized we don't really need to have a heap. We might be able to just use, we could just sort it at the end. So K weakest rows. I guess this has a, oh, and only if it's weak, right? So first we need to figure out, how do we know both rows have the same number of soldiers? But why is it saying both rows? This both rows thing is kind of strange to me. So we have 2 civilians here and we have 3 soldiers, right? So this is a weak row, and I guess it's weak. Do I determine? Well, let's see. I'm determining the weakness by the amount of soldiers. This one, I guess it's not weak, right? Because there's more soldiers. This one is weak because we only have a single soldier. This one's weak because again we have 2, and this one's strong. So 2, 0, and 3. Okay, weakest rows. Order from the weakest to the strongest. Now why? Yeah, them. Oh, the weakest would be. Oh, okay, 2, then 0, then 3. Why would 0, 2, 3? Why would 0 come before 3? Does it matter? Order from 2, 4, 1, 2, 5. The rows ordered from weakest to strongest are row 2, row 0, row 3. Do you just return the first instance of it? Yeah, I think we can make this easier. I don't know if we have to necessarily think about a heap here, but let's think about both cases, right? So what if we just get a score, and I think we can do this. If I start from, is there like a faster way of me doing this? What could be really cool is like, I'm almost thinking, I'm gonna go through each one of these and calculate the amount of ones in each row. That's gonna give me this score, right? But this is gonna be a linear time operation. So we're already going through, like, we're gonna have to go through each row. So it'll be row times n, where n is the amount of. So it's going to be an m by n operation to calculate all this. M by n plus n log n for the quicksort part, the quicksort piece of this. One thing that we could do, let's think about this. We could improve the efficiency of this. And I probably won't. Oh, no, we can't. No, we can't. For some reason, I was thinking about doing, well, no, what if we did, okay, it'd be cool, like, what if we did a sort of like a reverse binary search, because this is ordered, right, in increasing order from right to left, and instead of me having to traverse my whole array looking for the first one, I can just do a modified binary search to find the index of the first one. So that would effectively make it a row, right? We would find, and that would give us like the score, right? Because if the first one here is 0 and 1, we just add 1 to that, so that's 2. So it would be like row times log n per each instead of row times n. So that would definitely give us an improvement there. That's something that we could do. Like I said, I don't think I will do that for this question, but there's a lot of ways that we can go about doing this. I'm wondering if it's easier to go or yeah, do we even consider there's a couple different optimizations we can make, right? Because I don't even have to order. I only have to consider rows that are weak. What if I were to take the midpoint of any given row? If that's a 0, then it's automatically weak, right? Less than 100. Because then that means there's more zeros if the midpoint is 0, but what would happen if I had, like if I had 1, 2, 3, 4, 5, 6, you had 1, 1, 1. The midpoint here is 3, 0, 1, 2, 3. So would I say that this is weak if it has the same, right? And I think it says both rows have the same number of soldiers. Soldier in row I. Could we 1, 1, 1, 1, 1, and 1? Okay, let's brute force this and then we'll think about optimizations. I'm getting a little bit caught up here. So let's create a function here called count soldiers, which takes a row, and let's say let soldier count equals 0, or let I equals 0, I less than mat of row dot length, I plus plus. Here we'll say if mat at row of I is equal to 0, just return soldier count. And here we'll say soldier count plus or equals 1. Close this off here. Now we can just push this. We can create like a const weakest rows. We can say for let row equals 0, row less than mat dot length, row plus plus, const soldier count equals, let's see, count soldiers, or maybe like get soldier count. Oh my god, that's funny. Get soldier count. Here we'll pass in a row. And then what we can do here is we can actually push like weakest rows dot push. We'll create an object here and we'll say row. We'll push in the row and then the soldier count. And then at the end, we want to sort. What can we do? I want to sort it by. Soldier count, but return the row, right? 0, 2, and 3. Yeah. We can say sort of like const k weakest rows, or we can say parsed const sorted rows is equal to weakest rows dot sort. We'll take AB, but we want to sort it by A dot soldier count minus B dot soldier count. Soldier count. And I don't even need the curlies here. Could just do this. Sort A return. I'm definitely missing. Yeah, I do need that piece actually at the end. Oh man. Okay. And with this, just bear with me here. This might look a little bit weird. Let me just do this. Let's actually put this down here, because now what I want to do, this is going to return the same array with the whole object, but I just want the rows, right? So I can just do a map here where I sort of get my data and I just return data.row. Then here we can do return sorted rows dot slice from 0 to k. See what this does. 203. 0, 1. Here we get 0, 2. So it should, so let me see. I have at the end soldier count, so I'm getting a 1, 4, 1, 1. Okay. Get soldier count. for let row equals 0, row less than mat.length, row plus plus, const soldier count, get soldier count of the row, weakest rows dot push the row that we're on and the soldier count. So row 0 will be 1, okay. And then weakest rows, we'll sort it by soldier count. So we should have like 0, 2, 3, 0, 2, 3, 1. Okay. Oh wait, did I output 0, 1 and then 0, 2? Yeah, we should have 0, 2, 3, 1 because I'm doing it by soldier count. And then I'm just returning the row. The rows are 0 and 2, so we get 0 and 2. But I'm doing 0 and 1. Why is that? We were close too. Can I see what console.log sorted rows? How can I keep oh 0, 1, 2, 3 2, 0, 3, 1, 4. This is by row 0, 1, 2, 3. No, something's definitely off here. Weakest rows, let's also do console.log weakest rows. Let's do this. Let's remove this, and then for the test cases, I just want to get that second one there. I want to see what this ends up being here. Ooh. Interesting. Okay. Yeah, I think that's a nice little bug to catch here. If it's 0, return soldier count, but then we still want to return soldier count anyway at the end here, right? Let's see what this does. 0, 2, 0, 2. Okay, nice. 0, 2. So that gives us that piece. Let's remove this console.log. Let's remove that console log. 0, 2. Let's use all our example test cases. Two, 0, 3, 0, 2. Let's submit. 43.17. So okay, let me like think about this a little bit, right? So let's think about time complexity here. How long will this currently take right here? In the worst case, get soldier count will be an O of N operation. Like we saw, if we have all soldiers, that'll be an O of N operation. Okay, this here, M by N, this will be, yeah, this is going to be an O of M by N operation. Sorted rows, so sorting is going to be O of N log N for a quick sort, and then we do a map after. So that's going to be plus another O of N. So we have a lot of like, it seems like the bottleneck here is the sort, the N log N, potentially. N log N, M by N. Now, I think there might be an optimization that we can do here. Maybe I might only need to consider rows if they're weaker. Like if I have an even, let's say I have 1, 1 and 0, 0, but then we have 1, 1, 1, 0, 0, 0, 0, that's 5. If it's odd and the midpoint is this, then we don't even consider it, right? Like right now I'm considering all of them, even if they're strong, I guess. If it's 0, then it's weak, then we consider it. Here, 0, 1, 2, this is also weak because it has the same number. So if the midpoint, I think what we can do is I can say that if mat, let's think about this. Const midpoint equals to math.floor of mat of row dot length divided by 2. If mat of row at midpoint equals to 0, then maybe here we get the soldier count, since that means that it's weak. So we're sort of coming up with a little bit of an optimization to only consider rows that are actually weak, because if they're strong, it doesn't matter, because we want the weakest rows, right? That's literally the question. So let's run this and see what we get. 20302. If I submit this, oh, but a weak, really? A weak row can still be if it has the same. Interesting. Okay, that was a worthwhile effort there. I think then the other thing is, let's think about using a heap, right? If I'm, let me see. We know that insertion into a heap is a log n operation. Let me just remind myself, because I haven't used a heap in a long time. So insert operation has a worst case of log n. So as I'm going through, I can do m, like m by n by log n. Imagine I came up here. Imagine we'd like, let's remove all the new code that we wrote. Let's forget about this midpoint stuff. I'm going through every row. For every row, I'm getting every single soldier, so that's m by n, and then I'm appending that soldier count into a min heap. And then really at the end, we'll just have to do k operations to get the k things off of that heap. Yeah, that's what I saw. Amazing tutorials. Thanks a lot for joining. It's nice to see a new face here. So thanks for joining. And yeah, I sort of just realized that now, but thanks for the comment. Yeah, one thing I was thinking about here is whether we can use a heap or not. I would like to try using a heap, but only because in JavaScript it's not very easy to do so. And the LeetCode sort of support for that, while it's there, it has not been working for me for a while. And just for anyone that's like thinking of how they can get that, so I think it's like LeetCode platform features or something like this. Heap JavaScript. I wonder if that will heap priority queue. LeetCode, what platform? Oh, what environments? There you go. This one right here. This gives you the environments for each one of the different programming languages. So like for JavaScript, it does say that you get like priority queue and normal queues using these libraries, but it hasn't worked for me in like a long time. So that's why I just end up not using it. But that's one thing definitely to consider. A heap, probably a great thing to use here. So I'm gonna like this question. Awesome question. Gonna add it to the list. I probably should come back and do this with a heap, because that's such an important topic to know. So let us get to the next thing here. Oh, wrong button. Percentage of letter in string. All right. Given a string, it's nice to see a question with a short description. Given a string s and a character letter, return the percentage of characters in s that equal letter, rounded down to the nearest percent. Okay, so foobar, the length is what? Equal to is 2 divided by 6 times 100%. Really though? So it's just, we just need to get the frequency. 0, 1, 2, 3, 4, 5. Yeah, frequency divided by length times 100 rounded down. Is that really, that's really what it is? S, letter K. Okay. So let's call this const letter frequency. And wait a second, we don't need a map for this, right? We really don't need a map for this. Let letter frequency equals 0 for const C of S, every character of S. Here we can say if C is equal to letter, then we do letter frequency plus plus. So that gives us the count, right? So we have 2. And now here, if we get like 0, yeah, we can just do 0 divided by times 100. That'll still be 0 anyway. So I think we can always return math.floor of letter frequency divided by s.length times 100. And I wonder if we should do letter frequency divided by s length. That'll be floored, and then times 100. Yeah, that should still give us what we need here. 30. Okay, wait. Right, 2 divided by 6. Letter frequency is 2. For const c of s, if c is equal to letter, right, is letter frequency divided by s dot length times 100. Is it because I'm not? So if I'm going to do this whole thing, we can do that times 100. Let's try this out. $33 and $33. This one, it should still give us 0. 0 and 0. Submit. Okay. This was I mean, it's a great question, but you see how, like, for anyone that's been following on with me, right? Like, I think we can all agree that pretty much all the questions we've done so far are definitely harder than this question. So this is what I mean about, like, sometimes you have to remember a lot of these easy questions used to be mediums. And what ends up happening is people learn, for very popular questions, people learn the solutions to them, probably memorize them. They come in here, they solve the question, and what that does is it just like inflates the acceptance. It doesn't mean that it's easy, it just means that a lot of people have researched the answer because it's a very popular question. So that's why here we get this, like, I mean, this is very easy, this question. I would think so. Now, maybe I'm missing something that makes it hard. I wouldn't be surprised. Yeah, 12.21, there's probably something I'm doing like really poorly in here. 81.93, someone probably came up with some like bitwise solution or something. One-liner. Okay, yeah, that's exactly what we did. So I'm happy with that. Cool. But maybe that's a nice sort of like respite for us being here. This is cool. Percentage letter and string. Okay. Check if word. Yeah, that's the one we just did. Let's get to the next one. Nice high quality question. That's great. The letter value of a letter is its position in the alphabet starting from 0. So A is 0, B equals 1. Okay, cool. The numerical value of some string of lowercase English letters is the concatenation of the letter values of each letter in S, which is then converted into an integer. So for example, ACB, we concatenate each letter's letter value, 0 to 1. Okay. Return true if the summation of the numerical values of first word and second word equals the numerical value of target word. So 21 plus 210 is 231. Okay, I see. So actually we can do a couple different things here. So get word value, I suppose we can do. Let's make a new function called get word value. What we'll do here is a couple different things. We're going to go through word, right? 0 to 1. We have to, let's get our string value is equal to an empty string here. What I can do is for const c of word, I have to get the value of c, so const, or the character code, c.charCode at 0 minus 97. I might make a short about this because I use this a lot and I think it's very helpful. So c.charCode at 0 minus 97, and I can just append, right, string.value plus or equals code. And then here, what we should be able to do is we can just return parse int of string value and pass in our radix of 10. right? So we get the string value, we pass in the word, we go through each character of the word, getting its value, its code. C.carcode at 97, you can imagine that like C in this case is just going to be an integer, right? And this is a string object. So on that string object, we have carcode at 0, which is effectively the carcode of the thing in the 0th index, which is this. This gives us like decimal value 97, so we subtract 97 to make it 0. So then it's normalized. So here would be 0 to 1, that's 21. Parse int should handle any leading zeros here. So then really at the end, we can say return get word value of first word plus get word value of second word is equal to get word value of target word. I believe it should work like this. True and true. True, false, true, true, false, true. Let's run it. 31.54. Let's think about our time complexity here. So get word value, we're going to go through C of word, right? C of word, we're going to parse in. So it's really just O of O, it's N, O of N, where first word is, where N is like the amount of characters, the length of first word. Now, all of these are different lengths, presumably, right? I don't think they're all the same length. Now, yeah, I guess I was almost going to say, like, is it bounded by 8? Could that be considered constant? I think here, really, it would be O of M plus O of N, or O of, let's say, XYZ, O of X plus O of, here, I think just to write it out, O of X plus Y plus Z. This is what I think the time complexity would be, right? Because each one of these presumably have different lengths. So it would be O of X plus O of Y plus O of Z. And this will be our time complexity here for this one. So pretty happy with this. I think this is a solid solution to this question. Probably other languages handle it better, but I like the percentages I'm getting here. Probably going to make a short about this just to show how we can get the value of a letter in JavaScript. So yeah, pretty cool. I think I'm going to end the stream here today. Let's refresh this. So we started today at 105 and see how many we got to. I think we did at least 5. Okay, we did 4 today. So yeah, some days we'll have, you know, I know we've done sometimes like 7 questions, sometimes 8 questions. Today we've done 4. I mean, we have to chip at this every single day, but we'll, you know, we're getting there, and I'm really happy about that. So thank you all so much for joining. If you joined today, really do appreciate all the support you all have given me. If you like what you see, you know, subscribe, join in on the fun, tell your friends. I'm going to continue doing this daily. It's very fun for me to do. I feel like it helps me a lot in my own understanding, and hopefully it has helped a lot of you all. So thanks again. Have a great rest of your Sunday, everyone, and happy coding.